4 kilometers beneath the surface of the Pacific, in permanent darkness colder than a refrigerator, the seafloor is littered with billions of black lumps the size of potatoes. They look like nothing, like ordinary rocks scattered on an endless plain of mud. But inside each one is a fortune in metal, the exact materials the modern world is desperately short of. And right now, China is building robots to go down there and vacuum them up by the ton. Here's why this is suddenly one of the most contested frontiers on Earth. The batteries in electric cars, the magnets in wind turbines, the guts of almost every advanced device, they run on metals like cobalt, nickel, and manganese. Demand is exploding, and the land-based supply is controlled by just a few countries and a few companies. So governments are scrambling for any new source that breaks that grip. And it turns out the single largest untapped deposit of these metals on the planet isn't on land at all. It's lying loose on the bottom of the ocean, waiting to be picked up. So in the next few minutes, I'm going to show you 3 things: what these strange metal lumps actually are, and why they're worth going 4 kilometers down to get, the extraordinary machines being built to harvest them from the abyss, and the fierce fight, scientific, environmental, and geopolitical, over whether we should be touching the deep sea at all. Because this story is far from settled, and that's what makes it fascinating. If you like the resource battles shaping the future before they hit the news, hit subscribe. It genuinely keeps this channel alive, and that's the only time I'll ask. Let's dive in. First, what are these things? They're called polymetallic nodules, and they're one of the strangest resources in nature. Over millions of years, unimaginably slowly, metals dissolved in seawater precipitate out and build up in layers around a tiny core, like a pearl growing around a grain of sand. The result is a dense lump packed with manganese, nickel, cobalt, and copper. A quick note on that title. People call these rare earths, but that's not quite right. Nodules are mostly those 4 battery and steel metals, not the rare earth elements. Still exactly the stuff a green tech economy is built on. And they carpet the deep ocean floor across vast stretches, especially a zone in the Pacific between Hawaii and Mexico. We're talking billions of tons of metal just sitting on the surface of the seabed. Here's the part that makes mining companies salivate. A nodule can be over 30% usable metal, an astonishingly rich grade, while a typical landmine might process rock that's only a couple of percent metal, digging enormous open pits to get it. On the seabed, you don't dig. You don't blast. In theory, you just pick the lumps up off the mud. So the prize is obvious: richer ore, no drilling, an almost unimaginable quantity. The only problem is where it is. 4,000 meters down, in the crushing dark, where the pressure would flatten a submarine. Getting there is the entire challenge, and that's where the machines come in. Picture the environment for a second. 4 kilometers of water overhead, total darkness, pressure hundreds of times what you feel at sea level, and a seabed of ultra-soft mud so delicate that a heavy machine would sink straight into it like quicksand. No human goes down there. Everything has to be done by a robot. So engineers build enormous autonomous crawlers, machines the size of a small house that ride on wide caterpillar tracks to spread their weight across that soft mud. They're lowered on a cable from a ship on the surface and crawl slowly across the abyssal plain in the black. As they move, they use jets of water to lift the nodules off the seabed and suck them up. Hydraulic collection, basically an industrial vacuum cleaner for the ocean floor. The nodules are then pumped up a pipe kilometers long, riding a slurry of seawater all the way to the ship above. China has been developing this technology since the 1980s, and it's been testing hardware for years. Crawler vehicles running trials in the South China Sea, prototype collectors, kilometers-long lift systems hauling nodules up from the deep. A Chinese state-backed group has planned collection tests at 5,000 meters and beyond. The country holds more of these seabed exploration contracts than any other nation, with rights to survey huge tracts of that Pacific zone, an area holding hundreds of millions of tons of nodules. So when people say China is positioning itself to lead this frontier, that part is true. But, and this is where a lot of breathless coverage gets it wrong, China isn't dominating deep sea mining because nobody is mining commercially yet at all. And when you look at who's closest to actually starting, the picture flips. Here's the honest state of play. Despite decades of tests, not a single company on Earth is commercially mining the deep sea today. It's all still trials and prototypes. And the reason is a gauntlet of regulation, cost, and fierce opposition standing between we picked up some nodules and we run a mine. Most of the international seabed is governed by a body called the International Seabed Authority, which for years has been slowly, very slowly, trying to write a rulebook for deep sea mining that still isn't finished. No finished rules, no legal commercial mining in international waters. And in a twist that cuts against the China dominates story, the companies pushing hardest to start have been Western-backed. One firm went to the United States government in 2025 asking to open commercial seabed leasing off American Samoa, the first request of its kind in over 30 years, right as a U.S. executive order moved to fast-track seabed mining permits. Another company, backed out of North America, has been racing to begin nodule collection under U.S. rules rather than wait for the international body. So this isn't a solved game with one winner. It's a wide-open race. China with the most exploration ground and deep state backing, Western startups sprinting to be first to actually flip the switch. And no one has crossed the line yet, which raises the question that could stop all of them. Because there's a reason this hasn't just steamrolled ahead. Scientists are genuinely alarmed. The deep seabed isn't the empty wasteland it sounds like. It's a living ecosystem, home to bizarre and barely understood creatures. Many found nowhere else on Earth, some possibly not yet even discovered. And those crawlers churning across the mud don't just lift nodules. They tear up the top layer of the seabed and throw up huge clouds of sediment that can drift for kilometers and smother life far beyond the mining track. The nodules themselves took millions of years to form and are, on any human timescale, gone forever once removed. Critics argue we could wipe out entire ecosystems we've never even studied to solve a metals problem that better batteries and recycling might soon shrink anyway. That's why dozens of countries have called for a pause or outright ban until the science catches up. And that opposition, more than any engineering hurdle, is the real thing, standing between these robots and the seafloor. The machines are nearly ready. Whether the world will let them loose is the actual cliffhanger.